Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of domain and range. So we have to find the domain and range of these two functions. So let's start with the left one. So the left function is p at x equals 2 over 3 times x minus 2 squared minus 5. Now this is a quadratic function and this equation is written in vertex form. So if you may remember, the graph of this function is a parabola, and it's a parabola that opens up because the a value of this parabola is positive, which is 2 over 3, and the vertex of this parabola is 2 comma negative 5. So we switch the sign of the number in the parentheses and we use the number at the end. Now we have to use this information to find its domain and range. So let's start with the domain. Now the domain refers to set of all possible x values for the function. A parabola is a graph that keeps getting wider as we move along the parabola. So as a result, it spans the whole x-axis. So the domain for a quadratic function is written in the interval notation as negative infinity to positive infinity, because there is no restriction on the domain. And for infinity and negative infinity, we always use the parentheses. And in the other format, we can write the domain as just xer. That means x can be any real number. Now we can write the range of this function. Now I can sketch this parabola just to give you a visual understanding of how we can find the range. The vertex of this parabola is in the fourth quadrant, so somewhere here. And since the parabola opens up, the sketch will look something like this. That means the lowest point on this parabola is negative 5. So this parabola will have y values greater than or equal to negative 5. So it only spans a part of the y-axis starting at negative 5 and up. So the range can be written in interval notation as negative 5 to infinity. So negative 5 is part of the range because that point lies on the parabola. Now in the other notation, the range can be written as yer, and y is greater than or equal to negative 5. So this is the range of this function. Now we can analyze the second function, r at x. This is a square root function. So let's start with the domain. So as we know, the domain is for x values. Now we know that square root doesn't exist for a negative number. So that means the expression under the square root must be greater than or equal to 0. So this is our inequality we have to solve to find the domain of the square root function. So we have to isolate x. So first we'll subtract 5 from both sides. So the 5's on the left side cancel each other out. So we get negative x is greater than or equal to, so 0 minus 5 is negative 5. Now we have to change negative x to x. So we should divide both sides by negative 1. There's an inequality property that whenever we multiply or divide both sides by a negative number, the inequality sign flips. So it becomes x is less than or equal to positive 5. So this is the domain of this function. So in the interval notation, we'll write it as negative infinity to 5, and 5 is part of the domain. And in the other notation, we'll write it as xer, and x is less than or equal to 5. So 5 can be part of the domain because if we sub in x as 5, we get square root of 5 minus 5, which is 0, and square root of 0 is 0. Now we have to find the range. Now this is a square root function, so the result will always be a positive number. So therefore the range will be any value greater than or equal to 0. So therefore our range can be written as 0 to infinity. And 0 is part of the range, so that's why we use the square brackets for 0. And in the other notation, we can write the range as YER, and Y is greater than or equal to 0. So this is the domain and range of this square root function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.